Make sure you're not clicking anything beforehand. What just happened right now was that I already had this clicked, the center point of the arc clicked, which then affected my dimension. So a lot of times when you click buttons, you have to make sure that you're focusing on the right things. So like I said, what example just happened right now is I already had the center of that arc picked. And when I made my dimension, I already had that 1 point specified. So by the time I made this line, it was already off. Because what I want to have happen is compare this line, this point, with this point of the origin. So make sure that you always have things unclicked before you make your dimension, or at least be prepared and understand that you might have already clicked something. So a dimension of maybe this point and this point, and their x-axis. We can specify maybe 160, and there we go. Now notice, it's still not black yet. We specified both points, but it's still not black yet, meaning it's still not fully constrained. So Marco, what am I missing?
You are missing the center point. You need to constrain the center point.
Exactly. So notice this. If I move that center point, what's going to happen? It can still change in size because that center point is changing, like essentially the diameter in a sense. So I need to be able to constrain that center point. Now, how do I do that? There's multiple ways. One way is just to specify the diameter of it, which is easy to do. Another thing is to specify the location of that center point, just as we did with this point. See, we specified the height and the width. So we can do the same thing. So let's go ahead and specify diameter. I can click the edge of that and say the radius, in this case would be radius. You can see the radius of maybe 100. Click that and automatically it becomes fully black because it's fully constrained. That's one option. The second option is to constrain this center point. So we can do is make a dimension of the center point to the centerpiece and do it like a combination of the two, both a y and an x, like a diagonal. Click it, fully constrained. I like the way it is, for example. We click enter. There we go. So if you have any questions, drop them in the chat or turn on your mic. We're really curious to hear. So far, what we covered is making lines of different types, circles or rectangles, all different types, and then being able to dimension and fully constrain them. Because like I said, if you have a really complex sketch, you can make all kinds of different things. You can have lines all over the place. You can have everything everywhere. And let's just say your sketch is perfectly made and you're proud of it, but you make the mistake of accidentally dragging a line and now everything is off. You have to go in, you have to drag it out, you don't remember where it was. So making dimensions are really important because I could dimension everything the way it is already and fix it in place, which is important to do because you don't want to accidentally pull something. I drag that point and your sketch is now screwed up. So let's go ahead and check out the last thing that I wanted to cover. That is the spline. Now, Marco, what is a spline?
A spline makes two lines combined at a smooth angle.
Right. So there's two different types. The first one we have is like interpolation. So for those of you that have taken a statistics course, you know what interpolation means. And for those of you who don't, essentially when you make a bunch of little dots or points on a graph, this fusion will make a spline that will follow a line that bases on those points. So that's what the fit point spline means. It's also like a regression line, if you guys know what that means. Essentially, it's what it is. And then the second one is a control point spline. It's basically using vertexes. So what I want to use is this one here. You have a lot more, in my opinion, you have a lot more control over this one. I tend to use this one. So let me show you what I mean by that. I can click points all over the place, and Fusion will automatically create a smooth line for me. Now notice, I clicked a point there. That was the point that I made. I made the point there, and I made a point there. So even though I made these points in these locations, the line is different. Well, why is that? Because these lines here, these dashed lines, these construction lines, are essentially the slopes of each point. So for example, if I pull this, I'm affecting two slopes at a point. Notice here, if I get this line here, and if I make it completely horizontal, then you can see that the slope right here is 0. Now, for those of you who might be taking the calculus course, you can see that this here is essentially the slope of the graph or the derivative. I'm not expecting you guys to know this, but in case you do, it'd be helpful to visualize. Essentially, when you make this here completely horizontal, you're going to make your essentially derivative 0. Like I said, I don't know if you guys understand calculus. I don't know if you know that, but if you do, then it helps to know that. So if I make this horizontal or flat, then I make my graph have a 0 initial tangent line. See that it's completely flat here? I can do the same with this. I can make it completely vertical, meaning that it's working like that. And the same goes with here. And you can notice I can control essentially the slope of each point. I think that's good. Let's see what else is there to cover. So that's with the spline. And this is useful for when you're going to be making models of things that don't have perfect circles or an arc, because you can imagine that not everything in the world is made out of perfect circles and arcs and rectangles. You have to have those weird, strange curves. And last thing we can try is that spline. Let's do really quickly. So spline, we can make a bunch of points, and notice how it follows me. Whatever point that I make, it makes a graph or it makes a line based on those points. Notice how like the vertex function, I can control the slope or the derivative of each point, which is useful. And it's like the other side, except like it has its differences between the two. It depends on what you need. Both are very versatile. So let's go ahead, exit out of that, delete that. Now the question is, let's see what else we need to cover. That's right. Oh, Marco, tell me what a mirror function does.
So what the mirror function is going to do, it is going to basically mirror what you're doing on one side and make an identical model of it on the other side.
Right.
Across the y-axis, I should mention.
Right. So, I mean, we'll do a quick example. Here's a rectangle. And what we can do is we can mirror that. The button's actually here in the top as well. We can mirror that. We can highlight the entire object. And then secure a mirror line. So if I want to have that rectangle, if you look back at my screen here, I can have this rectangle with this line here and mirror it across. So let's go ahead and try that. I'll select this line as an example. Go ahead and select that line there. Do I need to make another line? I'll make another line. So let's go ahead and make another line. A line going up. And like I said, this will be a construction line. I can go over here and click construction. Notice how my thing already changes. Make it perfectly horizontal. There we go. I'll click escape. And so let's mirror that. Let's go ahead and mirror that entire function. And notice how I don't click my mirror line. I select my mirror line. And there we go. And notice how it already predicts where my box is going to be. I click OK. And there we go. We have 2 points. And if I change the height of this, if I change the height of one box, the other box will change as well. Really important stuff. And if you notice here, which is really interesting, is that this left box is symmetrical with the right box, which we'll cover more detail later on as to how that works. It's kind of satisfying stuff. So let's go ahead, that's the mirror function. Next thing we can look at is a circular pattern. I'll make an example, and I want Marco to predict what I'm going to do with this because I have not, this is just fully improv. Let's see. If I make a line and I have a circle in place, and notice how I have construction on, let me turn that off. And let's just say I have this circle in place. Now, Marco, how could I use the circular pattern for this? And what is it and how can I use it for this?
So the circular pattern is, it's going to make an identical replica of the circle that you just made, but it can make it in it'll take that circle and it will revolve it around an axis.
Exactly. That's exactly right. So what I want to do is go to create and go to circular pattern. What I can do is, again, I can click this circle. That's for one object there. And it asks me, what's my center point? Well, I can click the select button. And now I'm going to look for that. In this point, it's here. I click that button, and notice how it already gives me 3. So I can say, I can increase this number, and I can increase from 4 to maybe 12 or something, for example. And so notice how it gives me 12 options. And I can change the distance between the two of them, the amount, and so it's useful stuff. It's useful for when, let's say you're creating, I don't know, a gear, for example, and you have to have multiple screw holes to put some screws in. So it's just for ease, really. So instead of making a point 1, 2, 3, and doing it 12 times, you can use this circular pattern to do it once, and a circular pattern to do it 12 times for you, which is, it's just for convenience, and it really helps out. And it also will reduce error. So for example, if you make a mistake in one of your pattern, in one of your circles, you're not going to have that here because it's all going to be exactly the same. So that's the example there. And
I think really quick, Lucas, I was seeing that
Yeah.
circle function. Wouldn't that be also useful for, let's say, if they're making multiple holes for bearings on a side plate for a drivetrain?
yeah, that could be true. So you would need, you could have a bunch of bearings, I guess, in place around. I'm not sure if that's what you mean, but yeah, a circular function would be good for like having multiple things in a circular pattern.
Oh, so you can make them linear.
I can,
Okay.
but that's when we get into later. That's right here
Okay.
is where we want to get into the rectangular pattern.
Oh, okay.
That would be better for what we want to do.
Yeah,
So
and I
remember,
was just-
circular.
I was just thinking of repeating a circle, let's say 0.125 inches, which is a typical size of a bearing.
Yeah.
That way they don't have to create or space them out, individually. It'll automatically space them out for you, depending on where you want them. That's where I was thinking about that. Because I know a lot of
Yeah.
teams use sketching to make patterns for their drivetrains, and they need the holes for the bearings included in them.
Yeah, that would maybe be more something like the rectangular pattern. That's actually an interesting question. So for example, if I go to here, I can go build it, for example. And if I check out I go to structure. And if I can look at a pattern plate or a C channel, for example, let's get a C channel. What I can do is, that is a good enough picture. See how it's a repetitive motion of the exact same piece every time? Well, if I wanted to make this piece here, I'm not going to take the time to CAD out every single one of those holes. It's not convenient in any sense. What I would do is I'd make one little square with all the holes and use a pattern to repeat it. So what we just covered right now was a circular pattern. So if I was doing that, maybe I would use a circular pattern to CAD out the holes surrounding each large center hole that you can use for bearings. I'd use maybe a circular pattern to make those screw holes. And once I have a certain set block, I'm going to repeat that block all throughout the entire rail, or C channel. So let me explain what I mean by that. Marco, let's say that I have a circle in place here, and I want to make a grid of circles. How would I do that?
A grid around the circumference of the circle?
Like I want to make I want to repeat the circles like a grid, like fashion.
Oh, so what you could use is you could use the rectangular pattern and then apply multiple of the same item, because you can in fact use a circle or you can use any shape you want.
Exactly. Yeah, you can use any shape you want. That's a good thing. It's not just circles. Anything, whatever you make, you can rectangular pattern it. I'll click that. I'll highlight that. Hold on. We'll click that. I'll click that there. And notice how it gives me two arrows. I can pull that one up, for example, and notice how it already starts to give me repetitions of it. I can pull it up. I can pull this one to the right. So it's automatically giving me a 3x3, and I can control spacing. But what if I want more than just 3? What if I want 64 or something? Well, on the right, you see this little panel gives you, so you can change the quantity. So let's just say I want 8. There's 8 in the X direction. I want to have 8 in the Y direction. So now I have 64, but they're too cluttered. So what I could do is, one, I could pull it, or if I want to be more specific, I could put in a number here. I could say maybe 5,000, which should be enough. And I can pull it up a bit more. And there we go. There's our grid pattern. And so you can be more specific. You can say, I want the total distance to be 5,200 and something. And I want the quantity to be this much. And oh yes, you can also control spacing. So let's just say you don't know the total length, but you do know the spacing in between each block. We can specify that and say maybe 200. Obviously, it makes them tighter, but you can maybe do 800. That's too far. 800. And notice how it evenly spaces them. So that's a rectangular pattern. What's up?
I should add that this is going from the center point, not from the edge of the circle.
That's right. That's right. So notice how they're each being placed from the center point. Once I click OK, my computer is going to lag. I'm going to tell you up ahead, and it's going to take some. Oh, never mind. It's fine. So yeah. So here we go, and now it places each one of the center points down. As you can tell, none of them are constrained, so you have to constrain all of them, which isn't that hard. You'd probably have to constrain it beforehand, because when we initially created it, it wasn't constrained. But if we constrained it, then it probably would have been constrained afterwards. That's the patterns, and now that's what I wanted to cover from here. Of course, there's more options, more things you can go over, but that's what I feel is most critical. So essentially, these first four things are how you make your pieces. And if you have something really weird, you can use a spline function to make that. Something weird shape to make. And for convenience sake, there is the mirror, the circular pattern, and the rectangular pattern. So these there for a repetitive function. Instead of doing one thing over and over again, you can use these functions to make it quick. And it saves a lot of time. And of course, the dimension is absolutely critical. Something you have to understand. And that is, if I one more time, just to review, I click that dimension, and I can click this, and it specifies the measurement of something. I can give it a diameter in this case, and I can say maybe 500, or I can say maybe it's like I said, it's so important that you understand what a dimension is. I make a line of some kind, and I can give it a dimension, and I can say this line is so long. And notice how these dimension lines are there for you. So dimension lines are super important, and it's something you have to understand. Marco, is there anything I'm missing that you think I should cover from this create box?
You should cover the measure. Not from create,
right.
but it's from measure.
Yeah, that's actually really important too. Let's say, yeah, let's create a circle, put it over here. And so let's say we have something here, and I don't know how far apart they are, but let's just say that I like the distance that they're at. So what I can do is I can measure. See this little ruler button? This lets you measure anything. You can measure anything at all. And this applies for both sketch and for 3D models. So later on, it can also work for measuring volume. You can measure area. You can measure your two distances. You can measure radius, anything. This measure is super versatile and really important. Now, this box, it gives you 3 different points. You can select an edge, a vertex, a face, edge, or vertex. On the right here, you can click a body, or here you can click an entire component. Now, in this case, all we're going to cover is the first one, because all we have is 2-dimensional models. We don't have bodies, and we don't have components. That's later. So let's go ahead and see, well, let's measure this right here. I click that edge, and automatically it's going to give me some buttons. So there it says that say from here, from 1 to, let's say a center point from this circle to the center point of that circle. And it says 1,650 millimeters. That's really important stuff. Let's see, what else can we do? Let's try this. I click the edge of that, and notice on the bottom right corner, it says that I clicked a sketch arc. Technically, a circle is just a really complete arc, and it tells me its radius is 250 millimeters. I click, if I want to get rid of that, I click anywhere outside of the sketch. I click this box, this diameter, for example. It says my sketch arc is 350 millimeters. So it's a super versatile thing. Yeah, that's that. Anything I'm missing, Marco, for measure?
Sorry, really quick. Can you change the units of measurements? Let's say somebody's working in inches.
Yeah, absolutely. Yeah, absolutely. So in the top left corner on your browser section, you see this little gear button. It says document settings. I open that, and it says units. So if I want to change that, I can click that button there, and you click units, millimeters, centimeters, inches, foot. In this case, Most people using either inches or millimeters. We click inches, and you can set as default, which I'm not going to have, but there we go. You click inches, and now see automatically. See what's really cool is that my dimensions automatically convert from millimeters to inches, and now I'm no longer at 400 millimeters, but I'm now at 19.685 inches. It automatically converts. And something else I should mention is that if you want to create something, a circle, for example, and I click that circle, I see how it already specifies in inches. I can put a number in inches, 50 inches. And what's interesting is I can put IN, and it means inches. If I put MM, which means millimeters, it automatically gets super small, and it automatically converts to millimeters. If I put CM, it automatically converts it into centimeters. And I can put, I believe, what is it for yard? YD? Yeah, YD's yards. It automatically gets huge right there. And there's, I don't know, I have what I put for that. 2 yards, I forgot what I wrote. So yeah, there you go. So in case you have it, even if you have it specified as a different base units, if you type in your units after your number, you can automatically change it. But it's obviously easier just to change your default number. So we can say maybe 40 inches, or we can say maybe 2 YD, 2 yards. We can say 1000 mm, 2000 millimeters. So it's very versatile, and Fusion is a very smart thing. So let's just say enter. And there we go. And there we go. So in the top left section, your units recap, you click the button here on the side. You can change your active units, and it lets you change your numbers from units, centimeters, millimeters, meters, feet, and you can change your default to them. So there we go. Those are inches. One thing that's really important to cover is that if I click this face here, this is actually important. Marco, what's going on here?
It is highlighting everything within the circle except the bottom part where another circle is combined or intersecting within the circle.
Right. So why is this useful?
This is useful in case you want to create a certain object, or say you wanted to make a tool that had that stored Allen wrenches and you wanted to make it circular.
Mm-hmm.
You could cut out some of the circle so that way you can make a little pocket.
Yeah. Yeah. So like putting a sketch within a sketch will create a new face. What do I mean by that? Well, let's make a sketch, rectangle. Let's put a rectangle inside that rectangle. And notice, if I click this, see it automatically highlights. I created a new face. So it doesn't just highlight everything, it highlights that. And if I did want to highlight it all, then I would drag and highlight in case I needed all of it. But I mean, it's a very useful thing. So yeah, now did I cover everything from Create, Marco?
You have covered everything from Create, but maybe you should make it a little more nice and neat.
Sure. What do you mean by that?
You should probably trim some things.
That's right. Yeah, of course. Smart. So now what if, that's very smart. So we covered Create. So what Marco's talking about is he's talking about the Modify tab. So here you have a lot of options, and all I really want to cover is just one of them. That is Trim. I'll be honest with you, I've used CADing for a long time, but it wasn't until recently in which Marco brought up this trim function to me, which is new to me, and I've never, this is totally new to me, and that is the trim function. It's interesting. What you can do is you can get rid of excess material or excess lines. So let's look at this, for example. I have this circle here, but this huge circle cut out my circle. I don't want 2 faces, I want 1 face. So how do I get rid of this line that's intersecting my circle? Well, like Marco showed me, you can use the trim function. So Marco, how does that work? How does this work?
So you can either click the button at the top under Modify, or you can click T. And what you would do is, if you really wanted to make it a little more nice and neat, or if you wanted to cut something out that's so that way you could get a whole circle, you would click on that specific line and it'll cut out that line between the 2 points.
Exactly. So notice, like when I just did that, I cut out the line intersecting the 2 of them. We can do some more examples. I can get a line. I clicked, oh, by the way, like Marco said, there's different keyboard shortcuts. If I click L, I can have a line, right? And if I click maybe a rectangle, if I click R, I have a rectangle. If I click C, I have a circle, and there's nothing for arc. What else is there? There's spline for spline? No. But that's the important ones. So I'm gonna click L. I can just put a bunch of lines through my circle, and I'm gonna mess up the sketch. And I'm just gonna make things a little bit chaotic. Like Marco said, you can make things cleaner. So what if I wanted things the way they were, but I did not want any of these lines inside of my circle? I want everything to stay clean within my circle. I can use the trim function, that little scissor button, and I can click each line. And notice how the lines outside stay, but the lines inside disappear. So there's an issue with this function though. And the issue is that it's giving me a warning at the bottom. And that warning has a message and it has a meaning. That is, I'm deleting constraints when I do this. So notice these little dots, these little symbols around. Each of these are constraints. Now, I don't know if we have enough time to cover these. I really wanted to cover them. I'm still going to try. But constraints just help you fuse parts together. And so when I'm trimming these materials, I'm deleting constraints, which might mess things up. Might. So actually, let's go ahead and get into that right now. Let's delete that. Okay. Let's try an example of, let's try a fully constrained line. Oh, wow. Let's zoom in a bit. Okay. So let's say we have, this. And Marco, check this out. I'm going to have a circle here. I'm going to make things a little bit cleaner. Nice. Clean these things up. Now, Marco, I want to get this center point and attach it to the end of this line. How would I do that?
You want to attach the center point of the circle to the line. You could probably drag and drop it there.
You could. I think that works. Does that work? Yeah, that works. Okay, that works too. But you could also do, which I wanted to bring up, is the coincident constraint. Right here in the top right. So if I click constraints, this gives me a drop-down box, and it has all these different things. Well, what do they mean? Well, I'll show you an example of one, and I'll get into it. So like I just said, there's the coincident. And so you can click the center point and click the end of this, and it automatically puts the two of them together. Like Marco said, yes, you can drag it and drop it on, but it's also useful to know the coincident constraint. Now, here's what's really interesting. If I highlight this, or if I maybe click, see how can I get, there we go. If I click the center point, it gives me this little symbol. I don't know if you can see that too well, but that little symbol means a coincident constraint. That button right there. So what it does essentially is it gets 2 points and puts them together. Let's try another example. I have a line from here to here. Let's have another line from here to here. And I want to get this endpoint and attach it with this endpoint. The way I would do that is I would get a coincident constraint. So I would get this constraint, click that endpoint, and click that endpoint, and automatically Fusion joins them together. So the really cool part is that while you're doing this and while you're working on this, Fusion is already generating a lot of coincident constraints for you. I'll show you an example of this. One of like my interesting examples is that a rectangle. So let's build a rectangle. It might sound stupid to say, but I said that. So what we want to do is have a rectangle made of 4 lines, obviously. So let's make 4 lines, all completely random with no association to each other. So here are our 4 lines. Now, without any kind of measurements, how can I make a rectangle? Well, we know that a rectangle has 2 parallel sides. We know that it has 2 parallel top and bottom and 2 parallel, one pair here and one pair here. They're both parallel. We also know that each of the corners, that they're perpendicular to each other. We also know that each side are equal length on top and bottom, and equal length on side to side. Let's go ahead and try that. So let's say this is my left side. Let's say this is my top. Let's say this is the bottom side. Let's say this is the right side. So let's go ahead and put this together. What I want to do is say make these 2 parallel with each other. when I can use the parallel constraint. I click this button and I can make this line parallel with this line. And notice, automatically they move and you can see the little symbol pop up. I click escape, and if I move one line, or if I can drag around, okay. I'm not gonna explain what I'm doing too well, but I'm gonna fix that little point in time. And notice if I drag this side around, how it spins with the other. So it's always gonna be parallel no matter what I do. So these two lines are now parallel. What I do is do the top and bottom parallel, parallel, top and bottom parallel, another parallel. So what I want to do now is I want to have them perpendicular. I want to have this line perpendicular with this line. And now what's interesting is that this left side and this right side, since they're parallel with each other, if I make any move with them, they'll automatically be associated with each other. Let's go ahead and try that. This here is a perpendicular constraint, a 90-degree angle. I can make this line and this line perpendicular. And notice we're already getting a rectangle to take shape. But obviously it's really off and skewed. So how do I get this to be centered? What I can use is on the left side is the horizontal / vertical constraint. I can click that and I can click this line. Automatically, it makes it horizontal. Right, let's try it again. And I can make it vertical. I click that, make this here vertical. It knows whether it's vertical or horizontal based on whichever is closest to. And there we go. You'll notice how it's already getting close to taking shape of a rectangle. Now, the next thing we want to say is that each vertex, each corner of a rectangle is always touched together. So how do we get each vertex to touch? Well, I would use a coincident constraint like we just talked about. This coincident constraint, I can click that, click one piece, one vertex, another vertex there, and boom, they're touching. I click one vertex here, one here, they're touching. Do the same with each side, and there is our rectangle. There we go. So notice we have 4 parallel constraints. We have 1 vertical constraint. We have 2 perpendicular constraints. Now what's interesting is that we didn't have to do all these constraints for each side. We only had to do a couple of them. That's because it's associated. So like I said, these parallel constraints, for example, these parallel constraints make them always have the same angle. So if I make one perpendicular, that means they all will become perpendicular. And it's interesting if I highlight the parallel constraint, then it tells me the other parallel constraint it's associated with. Not the top and bottom, just the left and the right. So am I being redundant? Yes, because but it's interesting though, because like I said, Fusion automatically creates a lot of these constraints for you. So for example, if I click this rectangle button, now it's to make a rectangle, notice how it already has, see, this did it differently than I did. What it did is that it made the right sides vertical and it made the top and bottom horizontal. Now we can assume that these vertices are touching, which they are. So how do I know that's true? If I click a vertice, boom, there we go, a coincident constraint. So notice, this is really interesting because Fusion is making constraints for you automatically. So it's really good to know how to use them. That way you can know what it's doing. And the second thing is that if it doesn't make it for you, you have to make it on your own. So you have to know how to do that, which is why understanding these constraints here are really important. Marco, do you have anything to add on that?
Nope. Other than what was that lock for?
Oh yeah, I brought it up earlier. That way the parallels could move. So I had two lines, and I made them parallel with each other. In this case, they're off. Oh wow, this is working. So if what I want to do, I made them parallel, that line parallel with that line, and I was just trying to show that when I dragged one line, that the other line moved with it. So if I try to move this vertice, it was moving with it, and I was trying to make it to where it would have one piece stay stationary and then the piece move with it. So Marco brought up an interesting point, and that is this lock button, the fix button. So it fixes your constraints and where they are. If I click that vertex, it automatically makes that vertex stuck. No matter what I do, no matter what I try, that will always be stuck in place. So now if I grab this and I rotate it, it'll move. This is useful when you make a sketch that you like and you want to have it stuck in place, you can use the fixed constraint and have it fixed the way it is. An example of that is I could highlight everything that I have here. I click fix, and now everything turns green. And what's interesting, what's really cool is that technically this is now part of the graph of the coordinate plane that we're basing it on. So whatever functions or whatever rectangles I make based off of that should be fully constrained, or maybe not. Just this line would actually. Let's try from here, from this rectangle out. There we go. And so now these two are already constrained. The reason it's not fully constrained is that I haven't specified the dimensions of the rectangle. But if I do, it doesn't take long. If I say maybe 3 by 3, there we go. We have a fully constrained rectangle. And so this lock function is really important because it locks everything in place. Just to run things we're running out of time, so I'm going to run through this really quickly. Horizontal and vertical makes things horizontal and vertical. A coincident constraint makes one point attached on top of another point. A tangent makes a circle tangent to a line, or a line tangent to a circle. An equal makes two of anything equal to each other. So if I have a line, for example, a line here, I want to make this line equal to the line there. I use the equal constraint, make that line equal with that. And automatically, they're the exact same length. They have equal length now. To prove that, I'll click dimension, and maybe not, hold on. What I'm gonna do is have the equal constraint of this line and that line. There we go. Anyways, there's the equal line and there's the parallel, which we just covered, makes two things parallel. Perpendicular makes things perpendicular. The fix locks in point. The midpoint, which is I find very important and very useful actually. You put any line in the middle of a line. So for example, if I have a line and I want to put it directly in the middle of this line here, I can use the midpoint right here, and I can get this line and make it the midpoint of this line. It automatically attaches it in the center. The next thing we have is concentric. So basically I have two circles, two different types of circles, and I want to have the center points attached. I can get the concentric constraint and click the edges of each two, and they become in the center. They move together as one now. That's that. Collinear is also very useful too. It makes two lines completely next to each other. What I mean by that, well, if I have a line here, for example, I use a collinear line, a collinear constraint, to get this line with that line. And now they're completely at the same angle and the same position with each other. I can change their distance and the position, but they'll always be with the other line. Last thing is symmetric. So you can make, the symmetric is basically the exact same thing as a mirror plane. And curvature, that's for making things move slowly. It's useful for splines, not that important. Marco, anything to add?
No, I think you covered it.
All right. Question time. Anybody throw down a question?
Nope, Lucas, you are doing such a good job that there are no questions right now.
Okay, and there's one here that says, is there a chance that two lines connect to each other automatically? And if so, how can you reverse the effect? Marco, you want to answer that?
Okay, so if you want to reverse the effect, you could probably try clicking the undo button in the top left corner. If it was recent, but if it wasn't recent, you can click the little down arrow next to the undo button and it'll give you all of what you've done and you can click on one of them.
Yeah, so I click that. Undo constraint, coincident. And now it gets rid of everything. Oh, I shouldn't have done that. Hold on. Let's go and revert back to the. Okay. Also, another solution to that is if you have two lines, say one line here, another line there. Like I said, Fusion automatically creates a coincident constraint there. So notice I click that center point, it has a coincident constraint. How do I get rid of it? Well, I can click it and I can click delete. And now they have become two separate lines. Does that answer the question? Does anyone else have any questions? Anything at all?
Lucas, in the next training, you're going to go over how to combine two sketches, let's say a circle and a rectangle, and how to extrude them to make holes?
Yeah, we can
Okay.
cover that. So this session was just about 2D stuff, just sketches. The next session will be covering how to make those 2D sketches and make them three-dimensional. So that will definitely be covered in the next session. Should I cover that now?
I think it's better off for the next session, because I know that takes quite a bit of time.
Okay. Are there any questions?
Any other questions from the attendees? All right. Well, not having any more questions, Lucas and Marco, thank you for today. That was a lot of good information. As a reminder, this will be posted on our YouTube channel later today. Please, in the comments section, please post your questions. And if there's questions in there, we'll make sure they get over to the Patriot Engineering team. And again, student-led content is the way to go. So if there's anybody listening that would like to host a session with us, please let us know by emailing support@firstrgv.org, and we'll be glad to set you up. And for today, though, I'd like to thank again Lucas, Marco, Mrs. Bergoa, a great coach and mentor, and also Mr. Jose Sanchez with Patriot Engineering as well. Thank you all, and we will see you back for another session soon for advanced use of Fusion 360.
Happy spooky season.